Okay, so we apply this formula times D.
Mm-hmm.
We substitute the values. N is 27 divided by 2. A1 is 25. N is 27 minus 1.
Minus
Common difference is 2.
1.
So 27 means 13.5. 50 plus say 26 minus this 52. So 13.5 times 102. What is this?
1,377.
1377. So this is the total number of seats. And he says if the price per ticket or so-called price per seat is 2,300. So the total sale will be number of seats
Mm.
times price per seat. So that is
Let's see. But is this correct? Yeah.
yes,
Okay.
yes,
316711 is 100.
317.
3167100.
So that is the total number of sale. What's wrong with this? Why? I mean, why do you think it is not?
Because
Uh,
the answer was 880.
there are 20 rows. Why did I write 27? That is a mistake. There are 20 rows. My bad.
Yeah, so it should be 20. Yes.
Yeah,
Yeah.
there are 20
Okay.
rows. So n is 20. Here it is 10, 10. So 102. That is fine. So it is 1020. Total number of seats, that is 1020. If you multiply them, that would be the answer. Can you multiply?
Mm,
That is 1020 times 2300. This is the answer, 234,600. Now, can you show me where did you calculate 880 the answer?
okay, so I did A1 25
Yes.
and N equals to 20 and D is 2.
Oh, wait.
So
One more mistake. Here it is also n. Here it is 20. 19 times 2, 38.
wait,
38.
I can't see what you're writing. Oh, there.
Now is it okay?
Yeah.
So here n is 20. 20 minus 1, 19. 19 times 2, 38. This is 88. So it is
Yes.
880.
880.
And
Yeah.
then 880, you can multiply 880 with price. That would be the total sale.
Okay. Okay. It's
Got
good.
it? So
Yep.
you did the correct way. Why were you asking? That is fine.
I just put a question mark on it, and it was in the beginning when I did this, so maybe
Okay.
I wasn't really sure.
Hmm. Any other question?
Uh, Yes, N.
N. Mhm. Sherry works at a local fast food chain at the rate of 32.5 hour per hour. The management said that depending upon her performance, her hourly wage will be increased by $7.50 per hour every month. In how many months will she be receiving $85 per hour? So that is number N. Her monthly salary is 32.50. If she works better, next month her salary would be 7.5. If you add, it will be 40. Understand? In the next month, it would be 47.50 because it will increase at the rate of 7.50. So the
Yep.
common difference is 7.50. A1 is 32.5. This is her salary in the first month, this is the second month, this is the third month. So we are asked in how many months will she be receiving $85. So AN equals to 85. Understand?
Yep.
We need to know what term number is this 85. So
So it's the N, the result.
yeah. So 85, let me write first the formula. AN equals to A1 plus N minus 1 times D. 85, A1 is 32.5 plus N we want to know, minus 1, D is 7.5. So 85 minus 32.5. So 7.5 and minus 7.5. So here it will be 85 minus 32.5 plus 7.5, 7.5 N. So it would be 85 minus 32.5 minus 7.5, that is 45, equals to 7.5 N. So 7 divided by 7.5.
Are you writing now?
Yeah. So
I cannot see.
can you see now?
Oh, now I can see. Thank you.
So N equals to 6. If you divide 45 with 7.5, so and in 6 months she will be receiving 85. Is that clear?
Yep.
Any other question?
Let's see. I have a lot.
No problem. You can ask all questions.
Okay. G.
G. Uh,
I'm just very confused which
no problem.
formulas to
No
use.
problem. No problem. You just see which series are you given. Is it a arithmetic series or geometric series? And then you need to know either you are given the nth term, like in this last problem, like in this n number, we were given nth term like 85, or
And
some,
then you,
yeah,
yeah.
then we use the nth term formula. Sometimes you will be given the sum formula. So we need to see what we are given and then we use formula accordingly. Okay, so here number G is an investor earned Rs 6,000 for 1980 and Rs 12,000 for
No,
19.
wait. And a man borrows 32,760. G.
G.
Jordan.
I have, can you see my screen right here? Isn't it this one, G? An investor earned raised his
Jordan. So G.
E.
G. So from G and down 3. A man borrows.
Okay, J. We
Yeah,
call it J. How do you pronounce it?
G. But
G.
I'm not native English speaker, so
And how about this one, the one I circle? How do you pronounce it?
G. G.
G. G. Okay. So a man borrows these. Do you know Rees? Rupees. It is rupees. Anyways, a man borrows rupees 32,760 without interest and agree to repay the loan installment, each installment being twice the preceding one. What the amount of the last installment if the amount of the first installment is Rs 8? First installment is 8. The second one would be 16. The third one would be 32, 64, and so on. Understand? Because
Yeah.
it says that each installment being
It double.
twice the preceding one. Find the
Yeah.
amount of the first installment if the amount of if find the amount of the last installment if the amount of the first installment is 8. We need to find amount of the last installment. It means to we need to find what is an of the last installment, and man borrows rupees 32,000. And what is SN? SN is
32,760.
32,760, right? So
Mm-hmm.
this is geometric series. So we use the
Mm.
sum formula of geometric series, which is A1 1 minus r raised to power n divided by 1 minus r. Understand?
Yeah.
So 32,760. A1 is 8. R is, what is R?
Isn't it 32 divided by 16
Yes.
or 16 divided by 8 or
Yeah,
whatever?
so 2, very simple.
So it's 2, yes.
Yeah. So 1 minus 2, 32,760 divided by 8. So it is 1 minus 2 raised to power n. 1 minus 2 is minus 1. So here 32,760 divided by 8 is 4095 equals to, I can write this one as 2n minus 1. Do you know?
Yeah.
So plus 1 equals to this 4096 equals to 2 raised to power n,
Mm.
right?
Yes. Can you send the calculations in the group chat later, by the way?
Yeah, of course, of course.
Yeah.
That is why last time I was saying, even though in the next semester, if we go
Yeah.
into the regular classes, I will try to follow the same pattern. Like
Mm.
instead of writing on the whiteboard, I will use my computer like I am using this whiteboard, and you will see everything on the whiteboard on the projector. And then I can make the image of this whatever I will write, and I can share it in the WeChat. You don't need to write anything in the class. Like
Yeah, that's good.
normally when I write on the whiteboard, student always try to copy rather than listening to me.
Yeah, that's true.
So for example, here I can go simply into this. I can go into the export and I can make the image of this. And immediately you can get everything, whatever I will write. For example, here you can see, you can get instantly everything without copying. So it
Yeah,
is
that's
amazing.
good. Oh,
Okay,
I have another one.
I didn't finish this one.
Oh, so, yep. Sorry. And
So
then take this. Yeah,
now
go on.
I want to find out this n. And because I know this 6 is divisible by 2, understand? This
Yeah.
6 is divisible by 2, so I can write it 1496 divided by 2 is, can you see my calculator as well?
Yeah.
So it is, I can write it 248 times 2, understand?
Mm-hmm.
Furthermore, I can see this last number 8 is also divisible by 2. So I can further divide it by 2. So it is 1024. So I can write it 1024 times 2 times 2. Understand?
Yeah.
Again, I realize that this 4 is still divisible by 2. So I can again divide it by 2. So it is 5, 1, 2 times 2 times 2 and times 2. Are you following?
Yes.
Why I am dividing it only by 2 even though I can divide it by 4 as well? Because here I have 2. Here I have 2. That is why. Now again this 512, again this is divisible by 2. So further I divide it by 2, I get 256 times 2 times 2 times 2 and times 2 equals to 2 raised to power n. Now again this
Mm.
256 is divisible by 2. So I can divide it further and I can get 128. 128 times 2 times 2 times 2 times 2 and times 2. So 2 raised to power n. Now again 128 is still divisible by 2, which is 64 times 2. And here I have 1, 2, 3, 4, 5. I can write it simply 2 raised to power 5 instead of writing 2, 2, 2, 2, 2. Now again this
Mm.
64 is 32 times 2, and this 2 I can write it 2 raised to power 6. Again this 32 16 times 2, and this 2 again I can write it in the power 2 raised to power 7. This 16 8 times 2 times 2 raised to power 8. Then 4 times 2 raised to power 9, and then 2 raised to power 2 times 2 raised to power 10. And further you can see 1 and 2. So it is 2 raised to power 12 equals to 2 raised to power n. Is that clear?
Yes.
So when bases are same, we can equate their powers. So n equals to 12. N equals
Mm.
to 12. And he was saying that a man borrows this without interest and agree to repay the loan installment, each installment being twice the preceding one. Find the amount of the last installment if the amount of the first installment is, his last installment would be 12th term. Is that clear?
Mm.
His last
Yes.
installment would be 12th term. So I want to know what is the 12th term of this geometric sequence, r raised to power 12 minus 1. This is the, because this is the formula,
Mm.
a n equals to a1 times r raised to power n minus 1. So we want to know what would be the last installment, means the 12th installment. So a1 is 8, r is 2, 12 minus 1, 8 times 2 raised to power 11. So 2 raised to power 11 is
2048
times 8.
times 8. 16,384.
16,284.
384.
So that would be his last installment. He borrowed 32,716, and that would be his last installment. Is that clear?
Yeah, it's just a long process.
Kind of, yeah. Here we can see that you can skip this one. This portion was just for your understanding. This portion,
Okay. Yeah.
this portion. Otherwise, you can just skip this one. From here, we know that this is 2 raised to power 12, and you can directly jump into this one. You don't need to do all this. This is just for your understanding. I was explaining this.
Yeah.
Any other
Yeah,
question?
good. Yeah, it's pretty similar to that one, but N.
N. Sherry works at a local food. I already did number N.
Oh, wait. No, sorry. Wrong.
Mhm.
No, I don't have any more questions.
Okay, Kathleen,
Yeah, that's what's the one we did. Yeah, sorry.
any question? Kathleen.
I actually didn't really have any questions with series and sequences.
Okay, that's good. So if you don't have any other questions, so that is the last topic of our content course outline actually.
Yeah, that's good.
Yeah.
Wait, actually, I do have a question. So, oh, where am I? So I'm just looking for the pictures. That's okay. Actually, no, I'm fine.
Okay, that's good. So did you solve that one? This number 11, can you see my screen?
Yeah, we can see it.
This number 11.
I didn't make it so far.
You
I did
didn't what?
until 9.
Okay. Kathleen, how about this number 11?
Yeah, I didn't make it that far either. I did the pages. I like completed the page of like the ones that are like written out, and then I got to I think number 3 here, but I haven't gone down.
Okay, no problem. First, you can try it by yourself. We have one more tutorial. We can discuss it in that one. So if you have any question about mathematics of finance, we can still discuss that one. Otherwise, we can discuss
Yeah.
in the next section. Yes.
Yeah, we
Kathleen.
can, because I haven't checked the numbers a lot yet. So maybe if we can do that tomorrow.
Okay, no problem, Okay. We don't have any more students, so we may have more questions. So you can go through from all these, and because what I believe, I hope you can do this, or let me solve one. You can do the second one.
Yeah,
Because
good.
I think you could not do. You would not able to do that.
Okay.
For example. Can you see question number 11?
Yeah.
It says find the sum of the series. and series is in the form of 1 over 1 minus square root of x plus 1 over 1 minus x plus 1 over 1 plus square root of x up till n terms. There are n terms, we want to find the sum. Now there are two formulas for sum. One is for geometric sequence and the other one is for arithmetic sequence. Is that clear?
Yeah.
So first of all, we need to know, is it arithmetic series or geometric series? Who can tell me, is that arithmetic series or geometric series?
Arithmetic, right?
Yeah. No.
How do you know that it
Is
is
it?
arithmetic?
Because I think of arithmetic as like plus and minus, and geometric as times and divide.
No.
Because arithmetic is even, like it
No,
goes up even.
no.
No.
There
Okay.
is a very
You
simple
tell us.
formula. There is a very simple formula. If I write a sequence 2, 4, 6, and so on. If I ask you, even if this is series, if I put plus, I say, is it arithmetic series or geometric series? You will say that we are adding 2, 2, like 4 minus 2 is same as 6 minus 4. So their common difference is same. So it is arithmetic series. If I give you another series 2, 4, 8, so on, and if I ask you, is it an arithmetic or geometric? You say 4 minus 2, 8 minus 4.
Geometry.
They are not same, so it is not arithmetic. Okay, if it is not arithmetic, is that geometric? You say, okay, let me check. 4 divided by 2, 8 divided by 4, 2 equals to 2. Okay, that is geometric series and its common ratio is 2. So this is how we analyze any series, that is it arithmetic or geometric. But in that case, we are not sure is it arithmetic or geometric. Then we need to prove that. First, is it arithmetic or geometric? How we will prove that? We know that if it is an arithmetic, the difference of first two terms, like 1 over 1 minus x minus 1 over 1 minus square root of x, it should be same as the third term minus the second term. Is that clear? This is a2 minus a1 and this is a3 minus a2. That is what we do to check arithmetic series. Like here you can see that 4, which is a2 minus a1 and a3 minus a2. If their common difference is same, then we say that yes, it is an arithmetic series. Likewise, we subtract a2 from a1. Can you follow?
I'm confused.
That you can see this example once again.
Yeah, okay. Yeah.
I don't understand the radicals. So do we just ignore the radicals?
No, we cannot ignore them. Look at here. I give you a simple example. I give you a series. Let's say 2 plus 4 plus 6 plus so on. If I ask you, is it an arithmetic series? Tell me, is that arithmetic series? You say, okay, let me check. Is that arithmetic series? You take the difference of any two consecutive terms. You say that if I take difference of any two consecutive terms, it must be same, then it would be a arithmetic series. A2, this is A2, this is A1, this is A3, then A4, A5 and so on. A2 is 4, A1 is 2. Similarly, A3 is 6, A2 is 4. You say that 2 equals to 2. The common difference, if you take common difference of any two terms, it is same. So then we say it is an arithmetic series. Understand?
Yes. Yes.
Similarly for geometric sequence, if you have 2, 4, 8 and so on, and you want to check is it arithmetic or geometric, again you will see that you will take the difference of any two consecutive terms. It must be same if it is arithmetic. It is not arithmetic, right?
Mm-hmm.
Then we say, okay, if it is not arithmetic, then maybe it is geometric. 4 divided by 2, 8 divided by 4. Okay, the common ratio of any two consecutive terms is same, so it is a geometric series. Likewise, now I apply this concept here. I take the difference of this is A1, this is A2, this is A3. So A2 minus A1 should be same as A3 minus A2, like in this simple example. Is that clear,
Yes.
Kathleen?
No, yeah, I understand this. I just don't understand with the like x and the one take away radical x. I just don't understand that.
Oh, I will deal with that later. So far, did you understand the concept? Why did I write it in this form?
Yeah, I get it.
Okay.
I understand why you do A2 minus A1 because that's what you were doing before with the 4 over 2 and
Exactly,
8 over 4.
exactly. Now, apparently they are not same. Apparently they are not same, but if I do some algebraic simplification, you will see they would be same. How? Do you know this formula? A minus B, A plus B is equals to A square minus B square,
Yeah.
right? So similarly, 1 minus x, I can write it 1 minus times square root of x, 1 plus square root of x. Instead of 1 minus x, I can write it in this form by applying this formula. 1 minus square root of x, 1 minus square root of x times 1 plus square root of x is same as 1 minus x. So instead of 1 minus x, I can write here 1 minus square root of x, 1 plus square root of x, and minus this 1 minus square root of x as it is, right?
Mm.
Now I take its LCM. 1 minus square root of x, 1 plus square root of x. If I take their LCM, it will be 1 minus 1 plus square root of x. Understand? Understand?
Mm.
Not really?
Not really.
Okay. Look at here, don't worry. For example, I write here 2 by 3 times 5 minus 1 over 5, right? Its LCM is 3 times 5. Understand?
Yeah.
So 3 times 5 will cancel out with 3 times 5 and we will get 1. 1 will multiply with this 2. We will write here 2. Similarly, 3 times 5 divided by 5, we will get 3. 3 will multiply with this 1. So we will get 3 here. Is that clear? Do you
Yeah.
understand this one?
Wait, I don't understand why 3 times 5 is the lowest common multiple. LCM, right?
Yeah, LCM, lowest common multiple. 15 is the lowest common multiple for 3 times 5 and 5.
Oh, okay. So it's just okay. Okay, I get that. Okay.
Instead of writing 15, 2 by 15 minus 1 by 5. Instead of writing 15, I just write it 3 times 5 to make it similar to this situation. Now you can assume that this is 3, this is 5, this is 5, this is 3, and this is 5. 3 and 5 will cancel out with this 3 and 5. We will get 1. 1 will multiply with this one and we will get 1 here. Is that clear?
Yeah.
Is that clear?
Yeah.
Are you sure?
Can you explain again? I just don't understand. Like, that makes sense, but I don't understand why 1 over 1 minus x take away 1 over 1 minus radical x turned into 1 over 1 minus radical x times 1 plus radical x.
Just consider it a simple example, as I said. Look at here. Again, I am writing, you need to add 1 over 3 times 5 minus 1 by 5. How will you solve this? You tell me. Can you solve this one?
I would change the denominators to the same denominator. Would that be?
Okay. For example, you will multiply this one with 3 and here it will become 3. That is what you are saying?
Yeah.
Understand?
Yeah.
Carolina, is that clear to you as well?
Yeah.
Okay.
Because you need to have the same in the
Denominator.
bottom.
I did the same thing here. Now follow it in the same pattern. 1 over 1 minus square root of x. That is your 3. Consider it your 3. Understand? Just for your understanding. Is that clear? And
Yeah.
1 plus square root of x. Consider it, that is your 5. Minus. Now to make the same denominator, that is 1 minus square root of x, I should multiply here 1 plus square root of x, and here it will be 1 plus square root of x. Understand?
Yeah.
Okay, now Kathleen, tell me here, come back to this one. How will you solve it now? It will be 3 times 5, 1 minus, isn't it?
1 minus 3. Yeah.
And denominator is same, 3 times 5. Do the same thing here. 1 minus square root of x, 1 plus square root of x, 1 minus this. Is that clear now?
Yeah. Okay, that makes sense.
Okay.
I get it now.
So open the bracket, 1 minus square root of x, and it is 1 minus square root of x, 1 plus square root of x, and this plus 1 will cancel out with this minus 1, and we will get minus square root of x over 1 minus square root of x, 1 plus square root of x.
Square root of x. Yeah.
Understand?
Yes.
Now we do the same
Yeah.
thing on the right side. Now we do the same thing on the right side. Right side is, again we take its LCM. You can see before taking its LCM, I write it in the same fashion. I can write 1 minus x as 1 minus square root of x, 1 plus square root of x. And to make their denominator same, I multiply here 1 minus square root of x, 1 minus square root of x, and this one would be same. I am doing exactly same thing, nothing change. So denominator is same, like 3 times 5, and here it would be like this. Understand?
Yeah.
Carolina?
Yeah.
Okay, good. Open the bracket. This minus will cancel out with this. We will left with minus square root of x, 1 plus this, and 1 minus this. Now both expressions are same. both expressions are same, right?
Mm.
So this is your common difference, that is D. So we have proved it that this is an arithmetic series. This is an arithmetic series. Now we are asked to find its sum. Now we apply the sum formula and we can get its sum. The sum formula is Sn is n by 2, 2a1, n minus 1 times d. N is n divided by 2. A1 is 1 over 1 minus square root of x plus n is n. Now common difference we have just figured out is this one. Simply substitute the things and that is your answer. That is your answer. You can do the B part of question number 11 on the same pattern. Everything is exactly same. First you will
Mm.
prove it, is it an arithmetic or geometric, like the way I did, and you can get the answer. Is that clear?
Yeah, I just need to practice a bit more.
No problem. You can go over and in the next tutorial we can discuss the rest of the problems.
Yeah, perfect.
You can see I just converted it into an image, and
Yeah.
fundamental mathematics sequence. I can save it, and now you don't need to write anything as I mentioned it earlier. And here I can share it in the group. That is what I was saying, we will do it in the regular class as well. You don't need to write anything, and here it goes. Unable to send empty. Why it is empty? Image, export this one. There is a file. Let me try again. Here it goes. Now you can get it in the group.
Thank you.
I can stop the recording and I can, okay, I'm gonna end the meeting, right?
Yeah.
Okay.
I have a question.
Yeah, please.
So for Friday, are
Mhm.
we only gonna be asked to are all questions from the whole
Yes,
semester or just the last half?
last half, whatever we gonna include, we are including on
So
finance and
compound interest and sequences and series.
exactly. That's all.
So just those two?
Yeah.
Okay.
Okay, see you.
And no, but also matrices, right?
Whatever we have included in the first half won't be in the second half. I think uh, chapter 6.3 is included in your final, what I know.
Okay. Okay, good.
Yeah.
Sorry, I was confused.
Bye bye.
Okay. Bye. Thank you.
Thank you.
Bye.